I'm on my morning walk on High Rock Road in eastern Buckingham County. I'm about 1.5 miles south of my house, about a little over a mile south of the point at which we recorded the mica schist video yesterday. But here, even coming just a mile from there, we're in a completely different type of rock. And here you can see some of these rock outcrops over my shoulder. Let's go take a look at them and see what we've got. It's a little bit shaded, but you can see it's primarily a dark gray rock, not particularly strongly layered from this view. And I've got my foot in here for scale, but now that you can see how big this rock outcrop is, I'll pull that away. But this is just on the side of the road, this dark gray rock. There is actually some layering in here. If you look at this rock carefully, we'll pick up a little piece of it over here. And you can see this is just a little pebble really, but yeah, see, you can see some layers in this rock, and what we're seeing are some lighter gray layers that are dominated by quartz, SiO2, the most common mineral in the crust of the earth. Here's another very thin one down here, but most of the rock is a quite dark gray color, and that's because it's dominated by the mineral magnetite, an iron oxide that tends to form in certain environments where there's a lot of iron in the water when the rocks are being deposited, and if the water becomes super saturated in iron, it will actually precipitate out on the seafloor. So this is actually thought to be a seafloor deposit where quartz and iron oxides were being deposited on the seafloor. This is part of the Chapawamsik Formation, a belt of volcanic rocks in central Virginia. And yeah, so when we say volcanic and when we say seafloor, we think of volcanic islands out in the ocean and maybe even some subsea volcanic vents that are spewing forth mineral-rich water. So here we are in the middle of the Piedmont in Virginia, seeing a rock that may have actually been formed by a seafloor volcanic vent, by these hot mineral-rich fluids coming out and precipitating out on the seafloor. Let's take a look at a different piece here. I just picked this up on the side of the road, but here you can see the layering quite strongly. So you've got these lighter colored, probably more quartz-rich layers, and then these fine, darker layers that are more dominated by magnetite. How do we know it's magnetite? And why is it called magnetite? Well, I happen to have here my handy little pencil magnet. It's just a little magnet right there on the tip of a little plastic tube, and it's got this hinge on it so it swings freely. And I'm going to slowly approach this rock with the magnet. This is a test we do for magnetite in rocks. And look at that. The magnet is sucked to the rock, and that magnet really loves this rock. So that indicates that this rock has quite a bit of magnetite in it. Standing back from the outcrop a little bit, and it's a little dark, but you can see the layering in this rock is dipping off in this direction. I am looking approximately north 30 east, and I measured with the magnet on my compass. This is the strike of these rocks, about north 30 east, and the dip is off to the right here. I measured that. The layering is at about 25 degrees, dipping to the southeast. So we talked yesterday about the regional strike, in other words, a horizontal line drawn on a flat surface, a layering surface in this rock. And what's the compass orientation of that flat line? Here it's north 30 east. Yesterday we saw one that was about north 15 west, only about a mile from here. And that's because we're on a different part of this large regional structure called the Whispering Creek Anticline. Here we're on the normal southeastern limb of the Whispering Creek Anticline, where the rocks are behaving as rocks in the Central Appalachians should. They strike to the northeast and dip to the southeast. So here we are with a snapshot of the geologic map of Virginia showing a small portion of Central Virginia, Buckingham County, Cumberland County, the county line here, Route 60 here, Sprouse's Corner, Cumberland Courthouse here, And not to belabor this too much, but the Chapwamsic Fault is to our west and the Spotsylvania Fault is to our east. This belt of rocks in the middle is the Chapwamsic terrain, dominated by the Chapwamsic Formation, these metamorphosed volcanic rocks from about 450 million years ago. And we've got the two major structures, the Arvonius Syncline and the Whispering Creek Anticline. And where I recorded this video is on the southeastern limb of the Whispering Creek Anticline. You can see here from this geologic contact that the strike of the rocks in this area is northeast. From this outcrop, we're going to take a little walk into the woods. We're going to kind of follow the strike of these rocks up into the woods here, and just a few scant yards from the road here, there's a big mound of dirt here covered with trees and leaves. And right here, there's a big hole in the ground. This is a pretty big hole. I'd say it's maybe 15 feet by 12 feet across. I'm looking down into the hole. There's like a cave down there. Look at that. You could hide a large bear family in there. This is an iron mine from way back when. We don't have records to indicate how old this is, but we know that European settlers were in this area in the 1740s or so. So pre-Revolutionary War, the local people needed iron. We didn't have railroads to bring it in from the western mountains where there was later a lot of iron mining. So they had to find it locally. And so this is probably a colonial era iron mine. Here's a better look at that big hole. And hey, look, there's my shadow. So this is, this reminds us that geology isn't just an exercise to expand our brains or to help us philosophize about the history of the earth and our place in it. Geology has very, very practical applications. If you need steel, you need iron. And if you don't have a means of transporting it long distances, you got to find it locally. So knowing where this band of iron ore was, we would actually call this rock a ferruginous or iron-bearing quartzite. So knowing where this rock was and where it ran across the landscape would have been very, very important to the people in the colonial period. These layers of ferruginous or iron-bearing quartzite crop out or are exposed in many parts of central Virginia, and very often you'll find, if you trace them across the landscape, you'll come to a pit or a big hole where someone dug out some iron ore there many, many years ago.